So, welcome everybody. Thank you for being here at this talk in so large numbers. Data-oriented programming in Java. A bit about myself. My name is Veen. I'm a developer for a software company in the Netherlands for about 20 years in Java technology. I am what we call a special agent there, so we go to these conferences and do talks. And for the whole year, I've had this text on here, writing a book about migrating to cloud-native Jakarta EE. And it should be done in the third quarter of this year, which, of course, we are now in the last quarter, but we actually managed it. I do it together with my colleague, David Vlijmings. So we wrote the book, and it was an incredible experience, but that's for a different talk. But if you're interested now, you can pre-order it on Amazon. It will be released 17th of November, I believe. But today is about a different topic, data-oriented programming. So what is data-oriented programming? So it became quite, well, popular in the Java community around June 2022, when Brian Getz, the language architect from Oracle, he wrote this article on InfoQ about data-oriented programming. And after this talk, I really encourage you to have a look at that article, because it's really, really interesting. And the Java guys, they really pushed it. There's the Java podcast on YouTube from Nicola Parlo, and he had an item about it, where he talked about it. And at Java 1, then Gavin Bierman, also from the Java Oracle team, he gave a presentation. So it is clear that the Java guys at Oracle, they're really pushing for it. So this is our agenda for today. We're going to look a bit at evolution of applications to see where we're coming from. Then we're going to introduce a bit the principles of data-oriented programming. Then there is how does modern Java support data-oriented programming? Everything to do with the things added by Project Ember. And then we're going to look at some examples to round it off. I guess I should have said, if you have any questions, you can ask them on Slido. And select room 4. Password is, the room is GeeCON, and then room 4 for to get to the right area. Right, evolution of an application. And this is about how we used to develop Java applications. So this is Tomasz, and Tomasz, he's a developer. And he develops as an internal developer at the company. And he develops the thing that we all hate, timesheets, because we all have to enter our timesheets. And every week, or if you're lucky, every month, your manager will be pushing for you to say, oh, you haven't done your timesheets yet, right? So he had developed this application, and it's a simple one. We have a timesheet header, we have details, there's a user in there, there's projects, and there's some actions or activities that you can do. So we start off with a very basic model. And then one day, the project manager walks in and says, Tomasz, I think there must be something wrong, because I'm doing this project and there's this guy who's entering timesheets against my projects, but I don't even know him. So Tomasz thinks, and he looks at the code and says, yeah, you might be right. There's no connection between user and project. So we develop something there and we move on. And life is good again until the manager walks in again. And then he says, okay, I'm developing this API backend project, and there's someone with front-end design things, entering timesheets. So what's that all about? And he looks at the code again and says, yeah, have to fix something there. And that's how our applications develop. And then our company grows, so we get more people. And more people means suddenly we get more managers. There seems to be some relationship there that when there's more people, we need more managers. So suddenly there's not the users, there's now project managers, and there's approvers, and they have to do different things. And suddenly we go multi-tenancy, because it's such a success and we're offering it to the world. and our system keeps growing and growing and growing with parts. And this is how we did like traditional development, right? Our class diagrams, they just kept growing and kept covering complete walls. And if you look at the code behind it then, it could be something like this, where we did this object-oriented programming. So we had some data, and then we encapsulated it with the methods, and the methods that acted on that data. So like in this example, where we have an email and a password, and if a user fails to log on correctly, we'll increase some increment there and say, oh, is the maximum number of attempts reached, and then we'll block the account. So it's data and methods acting on that data, the classic encapsulation model that we used in Java. Going back to our classical monolithical application, so it looks like this object structure. But things have been moving, right? And more recently, we see this move to a different paradigm, which is more the microservices paradigm, or at least mini-services, at least away from the monolith. So classically, what you would do is that you would break it down in different domains. So we could have a user domain here, and we could have the timesheet domain, and maybe the core data domain. So all these things happen where we deconstruct the application into its smaller part, or the bounded context in DDD terms. So this is where data-oriented programming will come in, because it's a different approach. Because when your object models are smaller, which they typically are in a microservices application, then you tend to use a different approach. Okay, let's just see. Anyone here currently developing microservices? Oh, thank God, I thought no hands, then it would really be a bad talk here. But luckily there's a few hands there. Good. That is very good to see that we're doing something in that direction. Don't know if it's the right direction, but yeah, let's see. Okay, introducing data-oriented programming. What is this all about? Well, it's about 3 principles we'll talk about here. We'll just name them and then we'll dive into the details. Separate data from logic. Store data in generic data structures. And the data should be immutable. Well, as you can see, there's some principles there which kind of tend to go in the direction of functional programming. So data-oriented is really kind of an in-between between object-oriented and functional programming. So separating data from logic. So what does that mean? It means that you can reuse the code in different contexts. Classically, in object orientation, what we would do in the example above, we had this user, and if he signs on too often with the wrong password, he'll get disconnected from the system. Well, typically what we would do is that we probably would have some abstract class where this functionality is in, and then the 3 different types of users would inherit this functionality. Well, that's one way to approach it. Data-oriented programmer would actually do it the other way around, where we would say, I got this function, and then I'll pass in the specific class. So either a user, or a manager, or a project manager, or an approver. So that's a different approach. But the different context still allows you to reuse the code. And it isn't that different. I know right now it may seem like, that sounds weird, but I bet that you already might be using it. Well, testing in isolation would be another great example, or an advantage. And testing here is just made easier, because if you have this combination, the classical one, from data, so state and logic, then to create these test objects can be quite problematic. And it is way easier if you have the separation between data on the one side and your functions on the other side. And it tends to lead to less complex systems. The whole complex class hierarchy you had is being pulled apart, because Here basically we have the functions, here's the data, and there's not so much relationship between the two anymore. And then we have the generic data structures. Well, they allow for a more flexible data model. Of course, this depends on the language, because what would a generic data structure be? That could be lists or maps or stuff like that. But luckily, in Java, we have something else that we can use for that. But it makes it very flexible. And the other advantage is, if you would store data in lists or in maps, you could use like generic functions that could access the data and make it more generically usable. And immutability. Well, immutability is, of course, always important for a few reasons. You may change the reference to the data, but the data itself doesn't change, right? I'm here today. I don't even know what the date is, 20th, 19th. So today's the 19th, the first day of GeeCON. Even though we can change the reference, it will never change. GeeCON this year, the first day is on the 19th. So we shouldn't have that data changed. If we want to change it anyway, then we should return a new object, but never change the existing data. That's the idea. It gives you predictable behavior, because you can suddenly reason about the few places where data is actually mutated in your code. And of course, that gives you safer concurrency. If you're passing your objects around, but you never change them because they're immutable, you will never get to the race conditions, which makes your code safer. So, how does Java support data-oriented programming? Well, it does so in a number of ways. With records, sealed classes, pattern matching, and switch functions for pattern matching. Records. Anyone here familiar with records in Java? That's so good to see, because I think they've been there since Java 14 or 15, so that's quite a few years ago now. That's like 3 or 4 years, so it's really good to see that records have really been adopted. Okay, and has anyone then replaced Project Lombok with records? Yeah, there's a few people who would have done that, but most people still say, oh, Lombok is so easy, I'll just add an annotation and then we're, yeah, well, makes sense at some point. What is a record? Okay, I think if we can quickly skip through this then, because most people know. Well, a record is just a different type of class. So you say public record with a name, and then you specify the instance variables. These instance variables are final instance variables, meaning after the constructor completes, they'll have their final value, and you can't change them anymore. So they're immutable. They're really lightweight data carriers to transfer data through the different parts of your system. They have this thing called a compact constructor, where you don't have to tell the compiler what are the arguments to the constructor, because he knows. They're all the things you mentioned up above when you defined the record. So the compiler says, don't tell me, buddy, I already know. I'll take care of it. And so you can write a constructor like this. And what you're doing here is that you're basically validating the data that comes in. Now imagine you have a REST API, and it has a JSON payload. And the JSON goes into your application, but you want to validate it first. Records would be a perfect case for that. Because first of all, you can have your validations here. And secondly, they have a final value and they can't be tricked. There's no way that Jackson can use something like reflection to change values or set values that you don't know. Everything has to go via this constructor. You're in complete control. That's actually one of the benefits of using records over the add data annotation from Lombok. So it's way safer. You can check the data that is coming in. What you also see here is that we're not actually setting the instance variables, because the values we see here, email, password, attempts, they're the parameters coming in. And then the compiler, after the last statement, says, okay, if we made it to this point, I guess we're both happy with the data that came in, and I'll assign these parameters to your final instance variables. So the compiler does a lot of work under the covers. Well, creating them is as easy as creating a class. You just have to specify every parameter. And retrieving a value is just calling the name of the variable. And that's it. So records, very handy, super lightweight, and even less code than the add data annotation. Sealed classes. Anyone familiar with sealed classes? That is really a good number, because I just had this yesterday but at a different presentation, and I asked sealed classes, and I think only 1 or 2 people raised their hands. So sealed classes is a really interesting point, and you can see it actually more and more being used also in the JVM. David is later giving a talk about virtual threads, and actually there sealed classes are also used. What are sealed classes? Basically, if you have an object, you create your object and you can say, oh wait, am I going to share this with the world? I'll make it public. And if you say, well, I don't want the world to change my object, I'll make it public final. And then no one can touch it. Either everyone can do something and can inherit from it, or I'll make it final and then no one can inherit from it. Which basically means that that's kind of coarse-grained, right? That's really rough. Maybe you want to have a more precise control over who's allowed to inherit from you. And this is what sealed classes are all about. When you have a sealed class and sealed interfaces have the same principles, you're basically telling here after the name user, you say permits. Who is permitted to inherit from this class? And you have to specify the list here. And everyone, that is every class that is not in the list, will be stopped by the compiler saying, no mate, you're not allowed to do this. So, how does this then continue? Because after you defined the approver and the project manager and the regular user, what about them? Well, each of them has to specify how they will handle inheritance on their own. And there's 3 possible values. The most easy one is, well, again, just say permits. I'm a sealed class and I'll permit these subclasses to inherit from me. And suddenly you can see that we are constructing a very fine-grained hierarchy where we say who is allowed to inherit from whom. The second option is, let's just say, nah, this was enough. No more inheritance from me from this point on. I'll just make it final. Nothing new there. And then, and this is the question for the quiz for later, we have the option non-sealed. And non-sealed is the first hyphenated contextual keyword in Java. And basically what we're saying here is from, you know what, oh, this careful crafted hierarchy, I don't care anymore. Anyone can inherit from me. And it may feel like you said, well, I crafted this great hierarchy and now you're completely dropping it here, which basically isn't the case, because the compiler can always reason about that everyone that inherits from a regular user is at least a regular user. So the compiler knows and it can reason about it within those boundaries. And why that is important, and it has everything to do with the question of exhaustiveness, we'll get to a bit later. Because then the next thing that was added to Java in Project Ember was pattern matching. And it started in Java 17, where we had this first part of pattern matching, which was the instance of operator. Now, what is pattern matching? Well, basically, we have a predicate or a test, and then we need an object to test against. And then we'll use pattern variables. If the test is successful, I can retrieve one or more variables from the object I tested against. And these objects will be in the flow scope. And what that all means is, we'll look at a simple example. This is how it was implemented. Here we say, return user instance of approver. And if you look at it, and then we'll see that the predicate instance of This is not the instance of we were used to already having checking if something was in the right hierarchy. So this is a new one. And if this test is true, and we're testing against user, then we get a pattern variable A. And A will now be the user casted to being an approver. So it feels a lot like smart casting in Kotlin, for instance, or I think Scala has the same. But here it's different. It is pattern matching, and it is really, we'll get to records in a second, and then you'll see that it is being continued. So it's not just a simple smart casting. And the flow scope basically means between the square brackets there, this variable A exists, and afterwards it goes out of scope. So then we got the switch statement. Well, switch became an expression in Java. I think already in Java 12 or 13 we had the switch statement, and then switch became an expression with the arrow operator there. And basically here, and this is slowly where we get to the part what data-oriented programming is all about, we have these classes, and suddenly we treat these classes as if there are data. Because if you think about a normal switch, you have an integer and you say, is it case 1, case 2, case 3? And here we're saying we're getting a user object in, not even the values that can change, but the object itself. And based on that object, we are making decisions in our code based on the type of object. So it becomes way more than just a placeholder. It really has some reasoning behind it. Now, in this situation, we can say, oh, this user comes in. It can be 3 types. It can either be an approver, and in that case, the variable A there will be casted to an approver. Or it could be a project manager, or it could be a regular user. And here you can actually see that the compiler actually knows, wait a minute, there could be like 1 million classes that can inherit from user, right? And then, no, can't, because there could only be 3 types. And that is actually what the compiler is checking here. So for this situation, you don't need a default value anymore. The compiler can check exhaustiveness. And then in Java 17 or 18, we also got this thing where if you look at the case approver line, it says when. And that's a guarded pattern. So suddenly you can actually enter conditions to your pattern. So here's a guarded pattern, and it says case approver A, and when A is active, then return true. And then on the next line you see A again. Can anyone think about why approver has to be in there twice? Sorry? Yes, because basically the first approver, very good, the first approver says, oh, I'm only picking one that are active. So the compiler would say, if you leave the second line out, it would say, wait a minute, what about all the approvers that are not active? So the compiler actually checks that. So very good, thank you. And it's quite important, actually, if you would change the 2 around, the compiler wouldn't complain and it would never get to the second statement. So, yeah. But pattern matching went on, and it went on to records. So it could be like the easy instance of that we already knew. So here we say user record. If you're an instance of this, then I'll use the UR. But we could also start writing code like this. And this is very interesting. Well, first of all, the first case, we can now check for null within our switch statement. Before you enter the switch statement, you had to check for null. Otherwise, you will get a null pointer exception inside the switch statement. Now you can just say, oh, is it null? Well, then just do nothing. But the next line, it says, okay, case user record, and then it lists the 4 variables. So what is this? Is it just repeating here the definition? Well, actually, it is not. What it is saying here is, if the object you're sending in is of type user record that contains 2 strings, a boolean and an integer, could you then please unpack that object into the variables E, P, B, and A. So suddenly they become local variables. So it really deconstructs your objects into variables. So it's like the opposite of a constructor, right? And then you can use them as you see fit. But it didn't stop there, because it was still a lot of coding, right? And you had to remember, oh, wait a minute, what's the name of the variable and what was the type? So they then improved it and they said, no, you can now use the var keyword here as well. We could already use it for local variables, used it in lambdas, and now you can also use it here. So you don't have to remember, again, a string, integer, whatever, so you could do it like this. And then with Java 21 just released in September, it got even better, because in this case, we're only using the variables E and B, right? So we're not using the P, we're not using the A. And now, in Java, you can actually use the unnamed variable thing, where you use an underscore, and you say, well, you know, I don't care about all these other things, just leave them out. I guess Java stole this a bit from other languages, but hey, why not steal the good parts? And this underscore, which is a bit out of scope for this presentation, but it goes quite further. You can use it for parameters that you really don't care about. So you can pass it down. If there's now an exception, everyone has had this piece of code where they say, well, you do something with a try, you catch a null pointer exception. I guess you wouldn't catch them, but illegal argument exception, and then in the case you would have an empty switch thing or an empty catch clause, right? Well, now basically you can use an underscore for the exception. So basically, I know you're throwing an exception, but I don't care. I don't use it anymore. So it's in a few parts. I think it's like 5 parts where you in Java where you can use them since Java 21, and they're quite helpful. Right. Getting to the last part. So what does this all mean? What does it mean? All these features that Project Ember brought to Java, and what does it mean for data-oriented programming? Okay, let's go again over the principles. Separate data from logic. Stored in generic data structures, and data should be immutable. Well, separate data from logic. That could be done with static methods, right? Brian Getz actually in his article says, well, there's nothing wrong with static methods. I know we're coming from an object-oriented world, right? So using static methods somehow hurts. But there's nothing so bad against. And then also, who's using Spring Framework here? I guess there must be a lot of people, right? Right. So if you're making a service in Spring, you're annotating it, add component or add service. Those are stateless services, right? Most of the time there would be stateless services. So there's just some code, and then you pass it one of your classes, your data classes, and it works on it. Isn't it the same with in Jakarta EE or Java EE before? We had stateless session beans. Of course, we had also had stateful session beans, but no one used them because they're horrible to scale. But stateless session beans, right? Aren't they the same? Because they're by definition stateless. They're just some functions, and then we'll send some data to it that we want to manipulate, a user or whatever. And then that piece of code there, that stateless session bean with the methods in it, will work on that code. So basically, you might already be doing some kind of data-oriented programming without you even knowing. Okay, well, data should be stored in generic data structures. I read a book about this data-oriented programming, which was on JavaScript. And they said, oh no, we should do everything in lists and in maps and stuff like that. But that would be crazy in Java, right? Because we have a strongly typed compiler, and it checks a million things for us even before we run our code. So it would be ridiculous to not use that. So we should do it in generic data structures, because the alternative would be something like this, where you have a map. And of course, the map-off function added in Java 9 is a great thing to use, but it's not really very elegant code, especially if you want to retrieve the values, and it might be very error-prone. Luckily for us, we have records. I guess there was an idea that they got added to the JVM, to Java. Because data should also be immutable. that goes very well with the records as well, doesn't it? Because records are immutable. So basically, we can have like 2 out of the 3 principles of generic data-oriented programming, because it's not a principle unique to Java. It's like a normal language principle. We can use separate data from logic and use immutable data. And then the second part, well, again, with records, that's kind of almost of a generic data structure, right? Because they're so lightweight, it's almost easier to create a record than to initialize a map, for instance. So, to the examples. Brian Getz says in his article, in Java 8, the optional class was added. I guess we all know the optional. Basically, you're not sure if something is null or it's not null, so we wrap it in an optional, and then we'll check the optional first, saying, are you null or not, so that your code doesn't explode in runtime. And he said, well, if we would have had sealed classes and records and pattern matching available at the time of Java 8 when we introduced the optional, it probably would have looked something like this. We're defining here an interface of a generic type, opt. And the interface has 2 possible outcomes. Either it can be some or it is none. And in the case of some, it will have a value. So in code, it would look something like this. We would have a program that takes some parameters, then we'll call the run class. It would first validate some of the arguments, and then it would call the process method. Well, this is the skeleton. Looking at the code that's really interesting would be this, the validate method. It checks the command line argument. If there's no argument, oh, that's basically the null situation, right? So then we could say return opt none. So you don't have to do anything. You don't have to check. And if there is command line argument, you take the first one and you return an opt sum with the first argument. And then in your code where you process it, it can look like this, because there's only ever 2 possible values that this thing will have. It's either some or none, and based on what it is, you can reason about it in your code. So, the rules of data-oriented programming, and we'll look at another example. We'll model the data as data. So, our classes become data in the sense of the program because they drive the flow through the application. While the data should be immutable, we should validate at the boundary. Remember again the REST API that we said? There's this JSON payload coming in. You really want to make sure you validate it. Well, that's easy possible with records. So you want to validate at the boundaries, make sure it's safe, and then pass it on. And you make, and that's really important, make illegal states unrepresentable. I should really change that word every time the same. So what it really means is that in the example from before, it's either some or none, but nothing ever else is possible, which makes your code cleaner and safer, because, you know, if it's only these values that I have to check for, there can never be a third value. There can never be uncertainty, and your code basically reads easier. I think there's a section later from Marit about reading code. I hope she points out a few of these parts, because code is not just about writing. Of course, there's an enormous human effort thinking process in writing your code. That's really intelligent code. But after you've done all that thinking, there's probably like hundreds of people over the time that will look at your code. So if your code can express easily and clearly what it is doing, that's a lot of things gained. Okay, let's look at a final example. We say we have a REST resource, right? So some kind of REST API service that comes in, and it has a few functions. It has a search function, it has a create function, and stuff like that. Here again, we're defining a sealed interface, search results, and it is, again, generic. So it could be searching for your customers, for your items, for whatever data you have searchable in your system. And what you're doing next is that you say, okay, there's 3 possible outcomes. It could either be no result because you search for a primary key value that simply didn't exist. Or you could have an exact result. You search the customer on customer number and you got that customer. Or you search the customer on a name and then you got multiple results. But there's only ever these 3 possible outcomes. So this again makes very easy if you look at this interface. Okay, I know exactly what the options are here. And working with these options is really easy. If you, for example, would say, okay, I'll do a find projects here and I'll return an exact match. You can just create your project, stuff it into the exact results and return that. And then in your search method, where you are processing these things, you can say find projects with a value. And then again, it comes with 3 possible outcomes. And everyone who looks at this code says, oh, it's completely clear which path through the application I should follow to get to a certain result. I know exactly where to look if I'm going to have multiple results. So it makes your code really easy and understandable. And if you would take that 1 step further and, for instance, look at how to maintain data, then we get the same situation. So we had the search method, and now we want to store the data or create the data. Again, here's our REST resource that we had, and we're in the post method now. And then we can simply say, okay, master data. We can actually validate it, and if it's validated, we can store it. And in code, it would look again like this: a sealed interface. And there's a slight variation just to show you, because before we had the records inside. But if these records have some kind of logic, maybe you don't want to nest them, you can also have them defined outside. Just here, we have to use the permits clause then. So we say, no, a project that is permitted to extend master data and comes with all the information. Same applies to an activity and to a sub-activity. So there's nothing special about it there. But then again, remember, we had this piece of code. Then in the validate method can look something like this, where we say, okay, so what type is it? If it's null because it already failed at creating a JSON object for it or a record from the JSON object, it will be null, and we can simply say, nah, not valid. And otherwise, we can just simply, oh, project, then I want you to validate the project thing. If it's an activity, go there. So it's very clear again where you have to look and how the flow through the application is. And it's the same for storing. If you come in here, you don't need to null check anymore because you made it through the validation, so your data is good. So now all you have to do is say, okay, what type are you again? And then you can just go call store projects or store activity. So that's really powerful. And if suddenly you decide, oh, we're going to do something more, like we're going to add organizations, like an object to it, like a type, your program will completely fail because the compiler will say, wait a minute, you never implemented this piece of code. But it will point out to you everywhere in your code where you need to edit. Because if you look at the store method, and we would have organization now also extending master data, the compiler would say, you're not exhaustive anymore, because you're not talking about organization. But in truth, it will tell you every piece of code where it failed, so you can easily fix it. So, to summarize, data-oriented programming treats data as a first-class citizen. I hope that's the main part you can take away, that the data is flowing through your application and is driving choices in your application. Well, Java supports data-oriented programming via record sealed classes, pattern matching. And that was this part. And then we'll switch over to the Slido part to see if there are any questions. Let's see if that works. It does. Where's the Slido operating man? Oh, yep, here we are. If we are using only immutability and separating data logic, it's essentially just functional programming, maybe just with sealed classes on top of it. Yeah, like I said before, I think that's a very good question, because it is kind of it allows you to do object-oriented things. It also gives you the flexibility of functional things. So it is really this in-between thing. And one thing that Brian in his article very much wanted to point out is that Java can do both, right? There's nothing wrong with how we have been developing our applications until now. We have 25 years of legacy and history of Java. And that doesn't mean that we have been doing it wrong for the last 25 years. But different architectures might lead to different choices that you make on how to address your code. Is there still place for polymorphism in the realm of data-oriented programming in Java? It would be the same question if you would say, is there still room for polymorphism if I'm developing Spring with add-service method, or if I'm using the stateless session beans? I think there is still room for there. I think it is just different. And but again, object orientation, like we see it, there is always there will still be room for that. You can also mix it. It doesn't mean that you can only use like data-oriented programming if you're doing like microservices or anything similar. So I think there's plenty of room for both, and there's still a mix. And that's like always, you need to look at the trade-offs. Does the switch expression on sealed classes kill the need for the visitor pattern? Well, it is basically, that's a very good question. It is basically, it is a simplified visitor pattern, because basically now we know exactly where to look for the things that we need. So yes, it would replace the visitor pattern there. Very good point. What would the perfect case be to use data-oriented programming? Well, you tell me. I've shown you a few examples where you can use it. It makes your code very much more readable, in my opinion, and still scalable. So I don't know who came up with this question, but you could also turn it around. Show me a situation where you think it doesn't work. So we can always talk after the session. What about performance? If we have to always decide which type is an instance, well, it is not that this it is not done via introspection. So it's not that the JVM is looking, oh, what type of object are you again? So that's very much optimized by the JVM. And the longer your application is running, the more optimized it will get, and the C2 compiler will kick in and say, oh, I know these things already, and I cache them. So I think that would really won't be a problem at all. And then, how do you connect records with data persistence objects such as GPA entities? Yeah, that's a painful part, because basically the truth answer is you can't. And it has something to do with records, but maybe it has more to do with JPA. The JPA specification dictates that every class annotated as with entity, so it's an entity object, has to have a public no-args constructor. So that hurts records, because records basically only have one constructor, and it needs all the arguments. So the two don't match, because you can't have a no-argument constructor, because you can't set the values. So these two can't be combined. And then, what is the difference between data-oriented program and the DDD approach? I think it is, if we're looking at domain-driven design, that is just a methodology of how you look at your system and how you compartmentalize and make bounded context from your system, right? And so that would be identifying the different, let's say, subcomponents of your system. And then you can use data-oriented programming for in each of these subcomponents. So I don't think these are not competing technologies, nothing like that. Is creating new records when we need to modify them hard for the garbage collector? I guess creating a lot of objects always could stress the garbage collectors, but garbage collectors have moved on, right? I think there's later a talk about garbage collectors, and I think it's very interesting to look at, because I think these objects that are just been created short term, I think they live, depending on your garbage collector, in this what is called the Eden space. So and they can easily be moved away from there, and they get wiped out quickly. So I don't think it is such a big problem for the garbage collector. I also know that they are talking about creating a kind of builder patterns that's already, it is related, and then with so-called withers. So you would say user.with name, stuff like that, and so it looks like a builder pattern, which kind of may reuse objects. There's no JEP proposal for it yet, but I know there's been talk about it. Does data-oriented approach only make sense for modifying data? Would it still make sense to keep methods evaluating object state within object classes? I'm going to read that again. Would it still make sense to keep methods evaluating object state within object? Sure. I know I've shown a lot of switch things here. When you say, oh, now everything has to be a switch, no more ifs or whatever. No, it's not like that. It just shows how it can all work together. But no. Certainly, you can use records basically anywhere where you use classes, and you can use them in any way you want. Just remember the record deconstructor pattern I showed you. That can still be very powerful, and you can still make choices based on what you have retrieved there. So is the switch approach better than several implementation classes for each case and class record? Well, what is better? It's definitely a different approach. You have everything in one place, and you're making more use of the compiler here, because in the situation where you have like, okay, I have this subclass, and then I'll implement some child classes that implement it. If you would add another child class, like I said before, like company, the compiler wouldn't know about it. So it can't really help you say, oh, wait a minute, you forgot to implement a piece here, and there's something there that you didn't do. When you're using the sealed classes thing, the compiler will definitely point it out to you, mate. You should really fix that little piece of code there because you didn't look into that. So it's a different approach. And again, if we're building our monolithic applications, there's nothing wrong with making our wars and EAR files, because we have been doing that for 25 years. But if you're making microservices, they're definitely like a use case where I think the Java guys looked at this. And Java's definitely moving in that direction. We can see the micro profile which has been added to Jakarta EE. So they have realized there's this tendency to go to smaller pieces of code. And then I think this data-oriented approach with records and sealed classes actually makes sense. And I think that was the last question. So thank you very much for sitting here for so long and listening. Thank you.